hello friends. Today we are going to end our trainer by creating the user interface and wiring the functionalities in the user interface to our backend DLL. So, without any further ado, let's get started. Alright, for this let's create a new project. So this is our console application. So let's create a project that contains the user interface. Alright, so I'm just going to add new project. This will be a Windows 4 app and it's a classic desktop app. Alright, so this will do. So let's rename as trainer, and let's add the project output of the core and memory process core. Okay, this is our newly created project. So this is the newly created project. So I'm going to set this as startup project. So make sure that project starts when I double click, or rather just play button. Alright, now I'm going to add the reference. So I'm going for references, right click, add the reference. So this is the one I need, process and memory core. Alright, so I'm just going to click OK. So we have the reference added, and also let me add a NuGet package for Newtons of JSON. So what I'm going to do is I right click, manage NuGet packages, click here and click the browse button. So it should pop up Newtons of JSON. Alright, so the first one is Newtons of JSON, so that is popular, so I'm going to install this one. And okay, here. Alright, now Newtons of JSON is installed, so let's go to the form. Now let's start designing our user interface. So basically our user interface should look like this. So let's design the user interface like that. So this should be our user interface. Alright, so now let me close this one and let's design this. Alright, so Alright friends, now we developed our UI. Now let's start the coding, or rather wiring these buttons and stuff. So let's start. Alright, before we do anything, let's correct these three columns here. So as you can see, our data grid is this much of long, but these columns are not fitted to our data grid view, or rather it doesn't fully utilize the width of this data grid view. So let's correct that first. So I'm going to click this one. So let me rename my form before do anything else. Alright, so I click here. So this one will be, so first up I have to rename the frame. Yeah, this is my frame frm main. So the convention, and let me rename the class also. Right, so I have to again same frm main. So let me run this and check whether this one starts because we rename the form. Alright, it starts. Alright, so I believe this one automatically changed here. Alright, this is automatically changed, so no problem there. Now let me add the code to utilize, or rather correct the sizing of these three. So first let's click this and let's go to the resize section. So let's find the resize section here. Okay, or rather let's go for forms resize, because we need to resize if the form is resized. Alright, okay, now so let me find the resize column. Alright, this is the resize column. So I'm going to use for loop for int. Alright, so this one is filled for me. So this will be grid location infos, column count. So and is plus, right? So this is the column, and I set it weight to the grid's width itself divided by number of columns, so column count. Alright, alright, so this will do the trick. Now let's start this and try again. Okay, looks like something seems that our form loading code won't work, so form resizing code won't work here. So let me put to form loading code. There we have it. Alright, so the problem is our form is set to no fixed single, so resize method won't call there. So that's the thing, when we use forms resize, because the form is set to fixed single, therefore the resize method won't call, but in form load we can call, because it creates when the form is loaded. So this one works now. So as you can see, these columns utilize the width of the data grid view. Alright, so now let's start by adding the code and functionality to the load button. So I just double click the load button. Alright, so now what I'm going to do is I read the file, JSON file. Alright, so I read from the JSON and fill the user interface from the JSON. Alright, so before that, let me open a JSON file for you. So let us check what are the contents of the JSON. Alright, so this is the sample JSON here. So let me format the document. Alright, now this JSON contains this is the JSON start tag and the corresponding tag. So we have window name, so that will be that go to here, right? Window name. Oops, and mems, that means memory location. So mems, the mem dt, that means data type, and the value. Alright, so basically mem is this one. So this grid, now we are filling this grid, all right. So when mem's object goes for this grid, so mem means this one, memory string, all right. So as you can see, these memory strings, all right, this is memory string, that the string that we, the string convention that we created last week, all right. So that should go here, and the dt means data type, so this one, this column, and the val means value, so the third column, all right. Those should be filled with this JSON, all right. And the value column should be editable. Let's set the editable later. Now let's implement the load code. Now I double click this, all right. So we need to first create instantiate the open file dialog, so user can select any file. So let me instantiate that. So file, so this will be new one. Right now I'm going to add a filter. So this one should support only JSON, all right. So this is string, so you have to specify this as JSON file. Now this is the actual, where this is where you provide the actual extension here, JSON. So I'm going to get the result. Now this get the show dialog. Now it returns the results, all right. So now let's see if result is not equals dialog result cancel. That means user didn't click the cancel button and user selected the file, all right. Now first we have to clear everything in the data grid view. So basically let's clear this. So rows, let us clear this, all right. Let's get the file name. So let's get the contents. Contents equals, so we have to use the file. Let me import the file system.io.file. So let me read the all text. The file name will be, alright, will be the file name, alright. Now we have the contents, alright. Now we can create a class for these JSONs, but let's do some shortcut way, right? So in C# we have a data type called dynamic, alright. So we can convert this JSON file with to a dynamic object, so it acts like a anonymous class. So let's convert this JSON file to dynamic object. So I use dynamic, so JSON base is equal to, now remember we added a neutrons of JSON, so previously we added that, so now we are using one of their libraries, so JSON convert. So the JSON convert is not there, so I'm going to use control and dot and add this using neutrons of JSON, alright. JSON convert dot deserialize object, so get this type and get it to dynamic, and I pass the str file contents, alright. So I have this, now I have this dynamic file, alright. Now I can access this, so I can access the window names and mem. So mem is also object, it's also object, so, and it's an array, alright. So we are going to loop through the memory objects, alright. So now we access the memory. Now let's get the memory objects here. Var mem objects equals JSON bases, alright. Now you don't get anything because the dynamic object does not know what are the stuff. It can be anything, all right. So I am going to refer to JSON. So I am going to get the mems now, all right. So here I type mems. Notice the compiler and the evaluator won't give any errors. That is because this is dynamic objects, so any variable can be there. So therefore it won't give any errors, all right. So now let's fill one by one, all right. So now I'm going to use for each here, for each element, okay. Mem object in mem objects, okay. So now let's go to let's add rows one by one, all right. Now I'm going to, so we previously deleted everything, so now I'm going to rows dot add, all right. So basically new, so I'm going to use this overload. So this is the overload method I'm going to use, params objects values, all right. Now I'm going to use new string array notation, all right. All right, now I have mem objs. All right, now what are stuff? So first we need this, so let me grab this one here. So we need mem to the first column, all right. So first column will be mem or mem object dot mem, all right. Then second will be dt, I believe. All right, this is dt. So second one will be mem, so mem object dot dt, and the final one will be mem object dot val. So how do I get these values? All right, so I am simply referring this JSON file. So this is the mem, this refers to this one, mem object, and this dt refers to here. This one is dt, and val is the final one, as you can see, right, like this. All right, now once we after this for each loop, our data grid view now populated. Now let's set this one, all right. So this window name, so the text box will be txt win name, all right. Now I'm going to set the txt win names dot text, txt win name dot text equal. So the text will be now the JSON files, so the JSON's window name, all right. So basically we can get the window name from JSON base, all right. So we use the JSON base dot mem here, like that. We are going to use JSON base. Now the capital simple is first letter simple, window name, window, so w name, all right. So before go any further, let us start this and run this and try again. Sorry, try how it looks like. All right, we have an error here, so there is some problem. All right, I forgot to close the bracket here. All right, now let's start. Alright, now no compilation errors. So as you can see, our open file dialog is there, so the extension also there. So if I click desktop, alright, so this JSON file, so the game for pitfall, it's there. If I run it, you can see this pitfall, the mine adventure, and these values are there, alright. So as you can see, the byte values are loaded, everything. So now we can see these are editable. Now let's disable the editing of these variables, alright. So not the variable, these columns. So let me go to our design view and get the properties for this one, and let's go for columns, alright. So I click the columns here, and except this one, others should not be editable. So I'm going to set the read only to true here. Let's see whether that will do the trick. Alright, so now our load function working, okay. So alright, as you can see, these are not editable except this one. Alright, now this load button works now, okay. Now let's add these two. Alright, now let's add the functionalities to these simple stuff, and also fill this one. Alright, now let's add the functionalities to these two. Alright, now let me double click this. Okay, now we have to validate, so we are basically adding these values from this to this one. Alright, so let's just do a simple validation here. Alright, so I'm going to use if text memory operands. Okay, it's text trim value, length, or just we can say, okay, this string is empty. Alright, if we should do this if the string is not empty, and the value data types, again text, the trim, that means after removing space and stuff, also not equals string empty. Then we do the adding as this. Alright, let me check whether we didn't miss anything. Alright, so I'm going to add a row here. So let me simplify this. Alright, now I use the same version that I used earlier. So memory operand dot text, the memory operand. Second one is the data type, and finally this one, because we don't know what the value user inputs. Alright, so let us add the data type collection to this collection. Alright, so let me click this and go to the collection, items rather. So items will be, we are going to support what else type that we are going to support. We are going to support int. Let's start from smallest one, byte, and it's integer and float and double. Alright, so these are the types that we are going to support right now. So as a homework, I want you to add the other types and modify the write process and read process memory functions to those types. Alright, but there is a problem here when we run this. As you can see, these types, where you have to click to this combo box to get this type, and also you can type anything. So we have to lock the types here. So I'm just going to click this one. Alright, go for the property that lock. Alright, so let me check the drop down style here. Okay, alright, drop down style, I have to drop down list. Alright, now this is simply a drop down list. So here you cannot edit anything. Alright, with the letters you can change stuff. So let me add something here. So if I go alright, let's click the add button. So you can see the memory location and everything I added now. So I can adjust the value also. Right, now I can click the main window like this. So I can do the stuff. Now let's add the deletion. Alright, now let's add the functionality to deletion. Okay, let me double click the delete button. Okay, so if multiple rows selected, then we simply remove this. Alright, so if the selected rows count is greater than 0, okay, that means one by one let's delete. So let me add the open and close brackets for each. So this will be row in you have to get the count pair here. So this will be selected rows. Alright, and why we are having error now? Oops. So I remove the row, right? So this object, I pass this object. So let's start and let's load our pitfall file and let's try to delete. Alright, why this won't delete? Alright, that is because there's a problem with our selection style. Alright, so let's see the selection style, how our selection style set here. So the selection mode, right, row header select. So let's set to this one, full row select. So if I click anything, the full row will be selected. Okay. Alright, now let me get this. So if I delete that, so you can see everything can be deleted. Alright, so that's it. That's that. So we can delete. Now we can add anything we can do. So if I click add button, nothing happens. Alright, so I have to add both of these file too in order to add. Alright, so I can delete that too. Alright, now let's add the functionality to save button. Alright, so let's do the saving here. Alright, let me double click the save here. We need to get the row count to our grid view. If the row count is greater than 0, then and only then we are going to add. Alright, otherwise we are going to do nothing. Alright, so first let me check the row count. Alright, so let's check that first. So this row count, if this row count is greater than 0, then we are going to process the data and do the save one. Alright, so again I'm going to use dynamic objects because I don't want to create the classes for these each and everything. So I'm just going to use dynamic. So dynamic. So let's first declare the array variable, the variables for array, that means data in the data grid view. Alright, so now this will be expand. So I believe this is one. Let's see. Alright, system to dynamic expand the object. Alright, so how many items? Same as row count. Alright, now I have this one. So now this will be, so our JSON file look like this. Now we have, so this variable represents this one. Okay, and this one is also in a main another JSON tag, so it also has a parent. Now let's declare the parent. So dynamic so this will be parent is also new expand the object. Alright, now this is not an array. Alright, so now let's loop through each and every item in the grid. Alright, so for grd row count, okay, and it's going plus plus. Alright, now let's declare some temporary variables here. Oops. Now this will be our memory operand. Alright, so column index and row index. Alright, I know the column index always 0, the row index is now I here. So that value, that now this is object type, now I'm going to convert it to string. Alright, same for the two. So dt equals again, now I'm simply copying and pasting this one, except I change this 0 to 1. Alright, now again final the value. Alright, now this will be number 2, 0, 1, 2. Alright, so if let's do some validation for this value here. Alright, now I'm going to say if somehow user forget to enter the value here. So if I trim this one, if this equals to string.empty, alright, so I set the value to 0. Alright, okay. Now I add this one, alright, this information to this object, alright. How do I do that? So simply I'm going to use mem objects. So my first my index element is equals to, now again new expand the object, alright. So now I simply add, now I use these values, alright. So again mem dt world, alright. So now I will use, so let me copy this one because I am going to use that one. Mem, notice I don't have any compilation address, so I simply equals to mem dt is equal to underscore dt, world is equals to underscore world. Alright, so that's our dynamic object here, alright. So now we fill this one. Now let's fill the window name and add this object to this parent, alright. Okay, now how do we do that? Now first let's go get the parent. Now let's set the parents. So notice this one corresponds to this one, okay. This one, now that will be our name.text, again string value, alright. So now let's add this one to this one, alright. Now what is the variable name here, alright. So this will be mems, that will be the memories. Now let's set the mems equals mem objs. Alright, now these two added. Now let's serialize these as a JSON and save to a file, alright. First let's serialize these to string JSON, alright. Now I'm going to use a variable to store this tr.json, okay, that will equal to JSON convert, alright, JSON convert. Now I'm going to serialize object. Now reverse of deserialization. Now I have our root object is parent. Let me set the parent, alright. Now it's converted from here. I have the converted value. Now let's save this as a file, alright. So now here I'm going to use var save file dialog, so user can specify where he or she is going to save. Now it should be new save file dialog, alright. Again same as the above, we are going to set the filter. Oops, not the file name. So filter is again, this should be JSON, alright. Pipe star.json, alright. So let's set, now let's get the result again like previously. Var result is equal to show dialog. Now show dialog, right. So if result is not equals to dialog result.cancel, that means user didn't click the cancel button, user clicked save. Alright, now file, write old text. So the text, the file path will be save file dialogs file name, alright. The content will be str.json, alright. This should do the trick. And all right, let's check whether we can save and load. Now let's say all right. Now memory operand is like this. So data type will be float. So let's edit this, and another one that will be byte. All right, the value is here is 2.63.21. All right, byte will be 222. That's just it 2. All right, now let's save. All right, we can have the save dialog box. So test. Now it's saved. Let's open the test.json here. So this is the JSON file that it created. All right, let's right click and format the document. So as you can see, all are same. All right, except the contents are different. All these memory tags and all these tags, JSON tags are same. So let us try to load that one again, same file. All right, let me get the load. Okay, so test.json. So everything works as expected. Now let's do the interesting stuff. All right, let's wire the remaining buttons. All right, lock window, unlock window, reset pointer cache. I will explain this one when we do this one and read the memory locations, and finally the frozen one. All right, so this is the one actually does the job. All right, okay, now let's lock the window here. So let's start by locking window. So I double click this. So let's implement the coding for lock window. All right, so I'm going to use try catch here because I believe our process memory core throws an exception if it cannot find the window. So we can put some. All right, so we cannot find the window, so we can get the message box to say that the window finding failed. All right, so basically I'm just here get the catch the exception. So exception, simply I'm just print the box. So I click the box and tap to get the message box. So the content will be ex simply ex dot message. All right, so message is written from the backend, so that a message will be displayed here. All right, again, if I'm only going to lock the window if the text window name is not empty. All right, so text window name dot text trim is equals, so not equals to string dot empty. So if it's not empty, now I'm going to instantiate new object of memory processor. So let me declare the variable for our core memory system. So let me get the what is the class that we are using. So it will be core. So can we use, so using memory core, right? So core, right? So this will be our global variable for the memory class. All right, memory core class. So I'm going to instantiate new one if this is null. All right, so if core is null, then I'm going to instantiate new class with the window name. All right, now this is the other window name comes. So txt winName dot text dot trim. All right, so I added this one. Let me check whether this one works. So let me check whether the exceptions are thrown if I entered a wrong window name. We cannot find the window. All right, so what if we get the, so let's check with our trainer here. So CLR native mem is the file that we used as a reference to check our trainer. So the main, let's see the main. Can we lock the main? All right, we can lock to main. So can we lock to this one? we cannot. That's because our core object is not null. As you can see, let me close this. If and only if this one is null, then it's going to create new object, otherwise it won't. Alright, so with this one we can conclude this method, because this method is responsible for locking the window. Now it's locked with this one. Alright, so let me implement the code for unlock window. Alright, so again, unlock window, if exception or error throws, we can print it. Let's use the try catch as before. So I'm going to use try. So catch exception. So within bracket exception ex. So in message box, simply put the ex dot message. Alright. So if I'm going to check the null check here. Alright, if core is not equals to null, the null check is here. That's because if a user press the unlock mistakenly before locking the window, it will throw an exception in the program. So to prevent that, we use this null check. Alright, so if this is not null, so simply we can use core is null, but we should have something in memory core to release this. Alright, so let's check. Alright, we have a release method, so let's call that. So we are going to close the process handle when we call the release one. So basically we can use something like this. So core, let's release. Alright, this is the release. Okay, so let me check. So main, let's try to unlock, nothing happens. Okay, so let's unlock. Alright, so this one this does the unlocking mechanism. Alright, so no errors means everything works as expected. Alright, now let's discuss this one. Alright, so in order to do that, we have to do some small change in our memory core. Alright, so let me do the change in the memory core here. Alright, so this pointer cache, let me explain what is this pointer cache and resetting pointer cache is all about. Alright, so some games, so for example in Grand Theft Auto San Andreas, the funny thing happens to the pointers. Alright, so that is, assume that now you start to play the game. So you are running in ground, so you fire up your trainer and you freeze. Alright, so assume that this reset pointer cache is not there. Alright, so just forget about reset pointer cache and everything. So your pointer scan, or rather your trainer scans the pointers and get the values, and freeze updates those with the values that you are provided. Now it does with a 1 millisecond delay. Alright, now the funny thing happens when you are entering to a vehicle. Alright, so in GTA San Andreas, when you enter into a vehicle, your original pointer values get lost. That means those pointers are no longer pointing to the value that you found when you are in ground. Alright, they are pointing to something else. Now if you try to write to those locations, your game definitely crashes, because that happened to me. Alright, so in order to avoid that, we are using a pointer cache. It's simply a dictionary with a string and integer pointer to get the final pointer value, or rather memory location that holds the value. We are caching a pointer, so when you enter to a car, it does not make the game crash. So the caching pointer means this. So you start your trainer and you are in ground. You freeze the variables like this. So when the first iteration of the thread, it checks your dictionary whether you have this pointer cached in the dictionary. If it's not cached, so it goes through the pointer, multiple level or single level or whatever pointer, it finds the final address location where your value stores and cache that final address location in the intptr. Alright, so in intptr you store that location. Alright, now you have the location that contains the value, not the pointer. So the dictionary will be string and intptr, so the string value will be your memory operand that stores right here. Alright, so when now with that, it do just two things. First, it won't call the recursive function for each iteration, so it will speed up the process. So it simply get the read from value from the cache and get your job done. So get the value from the cache and update, get the value from the cache and update. The second thing is, if you do enter to a car, it does not scan the pointers, it does not go through the pointer. Since it go through the pointer cache, it does not crash your game also, and your values, the weapons and stuff, all are get updated. Alright, so therefore we must have the pointer cache. So but there are some exceptions to the pointer cache, so sometimes you must go through the pointers. So therefore we added a convention, we added something else to these memory operands. That is, if this memory operand starts from the caret sign here, so this sign, so if your memory location address start from this character, so if it look like this, then no matter what, this does not cache the pointer. Alright, so this does not cache the pointer, this go through the pointers and get the value. No matter you have the cache enabled or not, this one won't cache the pointer. Alright, so let's implement that cache code right now with this one. Alright, so let me change this code little bit. So we now need to add the caching. So first up, let's declare the dictionary. Alright, so let's declare the dictionary. So I'm going to add the static here. So private static dictionary. So my dictionary will be locked to string and intptr. So intptr is for storing values. So this will be pointer cache. Alright, why can't we get the string? So interchange two letters. Alright, so let's check. Alright, now here we have here, so when we are instantiating in the constructor, so everything, if everything is success, let's instantiate this dictionary too. So again dictionary, now we instantiate this. Now in our reading the pointer and get the real point location, or this method, so in this method let's add the caching. Alright, so this one returns if the caching, caching supported, that means memory operand string is not started with caret sign, and the memory operand available in the dictionary, then we won't go through these stuff. Alright, we simply return the intptr from the dictionary. Now let's implement that. Alright, now first up we have to check whether this one starts from the caret. Alright, so let me add a variable here. Okay, so this will be caching. So initially I set it to true here, so assuming that memory address won't start from caret sign. Alright, so now I'm going to check if memory operand starts with the caret sign, then that means no caching allowed here. Alright, so I'm going to remove the start caret sign. So memop.substring, so this is going to be substring by 1, and so I'm going to simply put the caches to false. Alright, so no caching here. So bottom, let's implement the cache code. Alright, so if that means else if it start from caret sign, or this memory operand is in contains key, that means it has a key of the memory operand. Alright, then simply return pointer from the pointer cache to this key. Alright, now rest of the code same, that means we did the return from here. If start with here, then cache, no cache in here. Now it's false to here. If the caching already, the cache pointer is already there, then it returns from here. Alright, now before we return here, now we have this final pointer. Now at this line, now when we reach to this line, this final pointer value is there regardless of how it find. Alright, last week we implemented how the final pointer works. Now here we have the value from anyhow we have the value. This is not null, that's for sure. Alright, so now let's use our cache variable. Now if the caching is enabled, alright, that means memory operand does not start from the caret sign. Alright, so that means caching is there. Alright, let's add this final point to our pointer cache. So simply add this with the memory operand. Alright, now our value is cache. Alright, so simply final pointer. Now here we should have, now that's all in this one. Alright, so in our button we had reset memory pointer cache. Alright, so reset pointer cache. Alright, so we should give something to reset the pointer cache. Alright, so let's add that method right below this one. So public reset pointer cache. Alright, so pointer cache, simply I am going to clear this dictionary. So then the caller functions need to evaluate. Alright, okay, now we are having small problem here. Alright, so what will be the problem? Okay, so here we have to implement some locking mechanism. So here pointer is getting added, and here below it will going to be deleted. So here it will going to be read. Alright, so we have to implement some sort of thread safe mechanism here in order to lock this dictionary. Alright, so let's add a locking mechanism here. So let me add a static object. So this will be private static read only object lock. So is new object. Okay, now I'm going to lock to this one. Okay, so basically, so this will be memory operand. So this is the one that reads. So before we returning, let's unlock this one, otherwise I don't know what will happen. So locks to lock. So let's see whether we can use this like. So I believe we cannot see the PTR variable, so simply I'm going to use int PTR. Alright, so let me remove this. So I'm going to return PTR. Alright, so it won't throw any errors. That's because anyway this should execute before this one. Alright, so I have PTR here, PTR. Now I return the PTR, right? So in writing, also when you're adding also, alright, if this one is cached, so I'm going to again lock to. So lock to lock. Alright, now this locking, now this is done. Alright, now finally when we are releasing, so lock to lock. So across the threads, this is static, so it will assure the thread safe. Right, now seems this end we completed. Now let's simply check the null. If somebody clicks the button without locking the window accidentally, alright, we should not let the program crash. Okay, so basically that means we are going to check the null here. So if core is not equals null, then what we're going to do is simply core dot reset pointer cache. Alright, so let me open this. Now not big deal happens here. It does not notice anything special, right? Now here, now read memory locations. So that's straightforward. We simply read the locations and save the values to this grid. Alright, so let me double click. Alright, so let's simply add the try catch. So if something happens inside this, so program should not crash. Therefore I'm going to use try catch. So I don't display any message here. So again, if the core is not null, then if the grids count, that means there should be multiple data columns in the grid. So we read the memory locations from that grid. So the row count is greater than 0. That means there are rows. If there are rows, then we are going to use read values one by one. So again, this one's dot row count. Alright, so here I'm going to loop one by one. So mem is equals to grt. So again, like earlier, 0 I. So you may recall this, we use the same thing for saving the values to writing values to JSON. So I'm going to simply click copy and paste. So this is dt. Alright, so now here this must be 1 here. Now dt is the determiner of what the function that we are going to call in our code, right? So if the data type is byte, we are going to call read mem as byte. So it is, if it is integer, read mem as int. It is float, read mem as single or float, or if it is double, read mem as double. All right, so like that, this dt is the determiner or determining fact of which is the function that we are going to call. So if let's implement first one. So if dt is an integer, so it is int, then the value, so grd, so this one's value, so 2, that means second column row index is again I, okay, I, its value will be dot read mem as int. Alright, so read mem as int. What is the memory address? So it should give the, it must give the operand, so this is the operand, so mem. Alright, so if it's null, then this will throw an exception. So let's check the null here. So ret is going to be, so this will be our return. So let me rename it from method. So if this is not null, so notice that this is int question mark. Alright, so if this is not null, so if from method is not null, then so this will be simply from method dot, we can use value here, or you can simply use this one. Alright, so I'm going to copy this thing, so this will be our common thing. Oops, not cut. Funny, the undo didn't work here. So let's try to optimize, let's try whether we can do some shortcut here. So if int is going to be dt, no, we didn't use it. Alright, so let's use else if. Oops, so it's else if. So if dt is going to be float, alright, if it is float, so this should be read mem as float. So I'm going to read memory as float. Alright, so from method is not null. Now this is the same. Alright, so simply what we can do is, so this one we can comment this var from method. Alright, so we simply can we can make this as object. So let's try that one, object from method. Alright, so I simply initiate, first I am going to initiate to null here. Okay, now I'm going to remove this vars here. Okay, so simply I grab this one and I delete this one from here. Okay, so this is some kind of a optimization. So let me optimize the readability here. Okay, so remove this one. Oops, so again else if dt is equals to now float. Now here we have double from method is equals to dot read mem as double. So again mem, no problem here. So else if, what's going on here? So dt is, so if this is double, now this should be byte. we have int, float, double, and final one is byte. Alright, byte. So from method is going to be core.readmem as double. Sorry, readmem as byte. Okay, simply mem here. Now here, after everything, if the final method is not null, so then we'll value the final method. Alright. So let's check whether this one actually works with our this program. Alright, so here what I'm going to do is I start this. Alright, so let's fire up the cheat engine. So let's why we fire up the cheat engine, that is because we are going to get the memory addresses for this one. Alright, so I don't know the memory addresses here, so no, I have a file for memory addresses, so I'm going to get those one. Alright, so generic, not the generic trainer. Okay, so this one. So alright, I have, alright, let's get the couple of values here. So I have this one. Okay, so basically I must add like this. Alright, so this one with 0 offset, so my memory window will be main here. Before doing anything, let's save this. Alright, so 4 byte means int 32, so integer add. So this is one value here. Let's get that pointer thing 2. Okay, so alright, what is this? Okay, this one something else here. So this should do it. 3F0. Alright, let's get this one. So 16 3F0. Notice this is not a pointer. Alright, so I simply do like this. I believe I don't remember how to add this. Alright, with the we get like this. So anyway, let's, if this one don't work, let's remove that. I honestly don't remember the adding notation for pointer here. So I believe the direct variables looks like this. Alright, so let's add the final one, the multi-level pointer here. Okay, so this is my multi-level pointer. So the basic pointer is 163FC. Basically 163FC. Now how many 4s are there? 1 2 3 4 5 6 7 8 9 10 11 4s and 1 0. So 1 2 3 4 5 6 7 8 9 10 11 and final one 12. So before doing anything, let's save this. So let's say clr mem.json. Okay, so let's close this and try our loading function, whether loading is actually works or not. So load here. So this will be clr mem. So everything's works. So let's log to window, no errors. So let's read. Alright, we get 18 here. Okay, I believe I forgot to add the multi-level pointer here, so let me add that one again. So we have to add this one again. So 6x3. So this one should be added. So 11 4s, 1 2 3 4 5 6 7 8 9 10 11 and 12, and the data type is integer. Alright, I believe I didn't click this button earlier, so let me save, replace the original one. So yes, I'm going to replace the original one. Right, so okay, so load. So as you can see, that one also there. So read. So I have this one. Let's increase these pointer values. Let's see, increase some, either this button will do the trick. So let's this one earlier. So I have these values. So this is, I believe, the progress bar. So refresh the progress bar, read location. So I have the progress bar, I have the this variable, static variable, that is 8, no problem there. And I also have the multi-level pointer increased here. Notice now this pointer is cached, so if I want to not to cache, I simply add this caret sign here. So if I let me demonstrate that for you. So this is the CLR mem file. So let me edit it from Visual Studio. So this pointer gets cached. All right. So if I add here like this, it stops caching. Okay. So each and every iteration it check for the pointer. All right. So read memory locations. So you see that there is 18 here, right? So why there was 18? That is because when I added this location here, I already read these locations, so it got saved. All right. So that's how we had the 18 save file. So lock window, read location, so everything works. Now this one does not support caching. All right. These two, however, supports caching because it won't start from the caret sign. All right. Now. Let me show the caching with the debugging on. So let's double click this core file. All right. So let scroll up to this method. So this is the where the caching happens. All right. So I put a breakpoint here. Okay. All right. Now let's do that multiple pointers thing. All right. So let me remove this caching disabling operator. All right. So I run this. So open. Okay. Okay. So cache. So double clicked the CLR mem. All right. So I am going to lock to the window. Now here I am going to read the locations. So let's go. Let's skip this one. Alright, so this is the memory location that we are in interest. So if we check our dictionary here, so pointer cache, we have two. So these are the dictionary that the variables that in the dictionary. Alright. So as you can see, if I go like F10, so this one has caching, so it does not start with caret sign. So we check whether this one has the key, so nothing found there, right? So now we are checking for the pointer. So this last week we discussed this, so I'm not going to discuss this one here. So if you are going to have more, if you need to know anything more about that, so I recommend you to watch the last week video. Alright, so now the caching is enabled here, so I'm going to add this to the point cache. So now this locked the thread, so other threads reading or deleting, deleting it now gets blocked. Alright, so I added this. So if I check the dictionary, now we have 3 elements, so this one is there. Alright, now let me run this. Alright, now if I try to, now let's no, not this one. So if I increase the pointer here, now if I try to read the location again, so here, now remove this, let's get to, alright, this is the location. So operand is here, this is the operand, so it does not start. So now here this condition gets true. See, that's because this dictionary has this memory operand. Alright, so then we are going to lock again. So we are going to get the pointer here. We directly get the pointer and return the pointer. So from that pointer it gets the reading, so we get the value of 38, which is same as this one. So that is pointer caching. Alright, so that's pointer caching. So if I remove these, so if I reset the cache, so I try to read one again. So here, if I go here, so this one again gets false, right? So let me show you what happens when we add the caret sign here. Alright, so if I add the caret sign, regardless of that what anything, the pointer, no matter what, pointer won't get cached. Alright, so clmem. Alright, so I lock the window, so read the location. So notice these two gets cached. Alright, so but this one won't. Alright, so now here this condition gets true, so memory operand is again normal, so caching is false. So we are going to the process all over again, and finally the caching is not there, so we simply return the pointer here. If I read again, notice we have the first one. So if we check the pointer cache, we have two, the previous two, first two only, the last one is not there. That is because it does not have we instruct it not to cache. Alright, so again this one has this one, so caching no longer here, so it goes to find the point. Alright, so from that it finds the value. So these two allow caching, while this is not allow caching. Right now we can read from the memory. Alright, so now reading is done. Now reading works. Now what about writing? So this is the most fun part, so the freezing. So let's implement this freezing. Alright, so let me double click it. So we have check change. So if the value is checked only, we are going to start the threads and stuff. Alright, so for this one we are going to use tasks. Alright, so we use tasks for we use long running tasks in order to implement this freezing method. So in a nutshell, we are going to create one thread per each memory location. Okay, I'm not sure whether it is the best thing to do or not, but hey, you friends out there, if this approach is not good, please write down in the comment section so I can learn from that too. So if you think that creating thread per memory location or altogether this approach is not good, so guide me to the correct path by commenting in the comment section. So for now I think this is not doing any harm, so assuming that I'm going to write this method as create each thread for each memory location. So now if first we have to check whether this one is checked. Alright, so if chk, so didn't I rename this one? chk freeze. Alright, if this one is checked, then that means we are going to start. Alright, now for each item in the grid, I'm going to create a thread. So the row count, so same as earlier. So I'm going to declare the private local variables, so same thing as like this. Alright, so 0 1 2, so mem dt and val. Alright, mem, so this will be dt and this is the val, so val and dt. Alright, so somehow if val is sorry, let's get the string value. So val string is string empty, then I am going to set the value to 0, otherwise it will throw an exception. Well, is going to be 0. Alright, so that's it. Now I'm going to use task factory here. So task factory dot start new, sorry, task dot factory start new here. Alright, so my lambda functions goes to, just for now I am going to use empty brace, and so creation options task creation options dot long running. All right, so this is a long running task. All right, now let's implement the others. So now let's implement this lambda method inside. So while this chk, that means check freeze dot check, while this one checked, you do this stuff. All right, so notice that this task factory creation is inside this for loop. So for each item, this creates new task, rather long running tasks. All right, so I'm going to create a try catch exception. Right, so no, we don't need try catch, I believe, because what we are going to do is first we read here. So last week we discussed the null pointer check. So we read the value. If it's null, so rather it does have value. All right, it's not null, then we are going to write. Okay, so let's try that. So if let's get the correct conditions here ready. Dt is again int. Now let's, oops, I don't know why my undo control is not working here. That's funny, rather. No, so else if, so dt is again equals is float and double and int byte. Sorry, else if dt is again, and finally the byte. So this will be a byte variable here. Okay, now so here let's add one by one here, some funny, oops. Okay, all right, now this is indented properly. So if this is so object read from method. All right, so if so I'm going to use the, since this is an integer, so I'm going to cast this as an int question. Right, can we do this rather? So if cast this as an int nullable int third, okay, has value, oops. All right, we can, I believe we can here. So why we have a use unsigned local reference. So let's, oh, okay, first we have to assign this somehow. So not so first we have to assign this. So basically, so read from method is code dot read mem as, so this should be int. Okay, what is the value we are going to pass? This is mem. All right, so this is it. All right, okay, so if this is, so if and again, so this one has value, then we simply write, so code dot write, so I believe, so this is write mem. Okay, so again this is mem, and so I have to pass this as int. So because the variable val is string, so I pass this. That's it. So let me copy this method, this code block here. So I simply remove the rename this. So read mem as float. Okay, so this one has value, so I am simply instruct the float class to pass the value. All right, so if this is the case, so read mem as double here, so double. Okay, so if this one has value, so simply double dot pass value. Okay, so this one is also same, so byte question mark, read mem as byte here. So everything is same here. So we could use some kind of template method. So just for now, let's use this one. So read mem as byte. So byte has, so simply I pass the byte. Now I forgot one thing. I have to change this one. So int question mark. So float question mark. So oops. So float here. Double question mark. So this is double. All right. So this is byte. So right now our locking and thread creation process now complete. All right, but we must add a thread sleep. Okay, 1 millisecond sleep. Otherwise, this one uses every process cycle, most of the process cycle, and this one stops responding. All right, so under this one, so here while here before ending the while loop, all right here, so I'm going to use thread dot sleep. Oops. So I believe we can use thread here, not the tasks. So thread dot sleep. So 1 millisecond. All right. So okay. So let's double check. All right, we have this one, and everything. I think we all. I think our all functionalities are now implemented. So let's try whether our locking is working or not by try to locking this process. All right, so I'm going to use the load function here. Okay, so this is the one. So notice I am not supporting pointer caching here, so let me crank up everything to 100 here. Okay, so everything should get 100. All right, so I lock to the window and I freeze. Oops, let me remove this breakpoint. Alright, now seems to be freezed. Alright, yes, as you can see, all 100 regardless of the button I pushed here, nothing changed. So I am not the progress bar won't change, the static pointer won't change, the multiple pointer also won't change. So if I nullify this one gets null, but no exceptions or no hangings here. So if I remove the freezing, then I can increase the static one. Alright, so if I freeze this one again, so alright, so this is the trainer that we started to create from the scratch. Alright, now so the trainer works with our CLR mem file, so the refer tester. Alright, the testing program. Let's see whether we can actually do this too, the game that we discussed when we start with the series, the pitfall. Alright, so let's load the pitfall mine adventure locking memory location file. So I double click this one. Right, so as you can see, every location gets cached. Alright, so in this game it doesn't matter whether you get the caching that's much. So let's ignore the caching for now. So I start this one, so let's play. It's that's weird. Why they ask for temp path? All right, let's see whether we can do. So you must have the CD-ROM. Da 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 da. All right, so I cannot find the image file, so rather I copied the crack file from the internet. So here it is. So I believe the crack file. Oops. Let me remove the compatibility settings here. Okay. So let me remove this. So I believe the crack doesn't do some instructions changes, not a variable changes. So if the crack changes the variable, then we are getting into trouble because our trainer won't work here. Okay. Alright, seems that everything maxed out here. Alright, so as you can see, so it's kind of works. So my health won't reduce. So I kind of have everything, but there is a problem right here. Okay, so what's going on here? Why our trainer won't operate correctly? Alright, so friends, after some tremendous time consuming and debugging, we finally found what is the issue is. Alright, so apparently the issue is in this method. Alright, so this method is the problem. So you see, we are writing 8 bytes. Alright, so we are writing single bytes to our process, but the way we retrieve the bytes is by using the bit converter again, right? So we could use simply this byte and create a new array with a single element with this byte. So that is because we are just using simply a byte variable, a single byte. That is, we need a byte array. That is, the reason is we need an array that is, our write process memory function requires a byte buffer, not a byte value. So therefore we must send an array. But here the problem is this bit converter get bytes function returns two element arrays. One is the actual value and other one is 0. So why it does this? So in order to find this, let's get the overloaded version of this get byte. So we have bool, we have char, we have double, we have float, we have int, long, short, unsigned integer, unsigned long, and finally unsigned short. But it does not have anything with bytes. Alright, so it does not have anything with bytes, so it simply convert this to something else and return that variable's byte. So this one, so as a result this gets 2 bytes. One is actual bytes, another one is 0. So that's why we get the flickering zeros and ones here. So if let me show you what I meant by that. Alright, so we load this pitfall file, right? So we lock the window and we freeze this. Alright, so notice we have 100, but if oops, so let me get this with the threads. Alright, if I click check this variable, I have 2 bytes. One is 0, another one is 100. So 100 and 0. So this 100 you will see as it's right as 99, and after that when it replaces with this, it overwrites that 99 to 0. That's why it varies between directly from 99s and zeros. Alright, so but we must send a byte array to our write process memory function. Alright, so let's get rid of this, so we cannot use this one. Alright, so let's convert this to, so simply new byte open close and send the value here. This will do the job here. So load pitfall and lock the window and freeze this. So let's see. As you can see, now there is no problem whatsoever. So we have everything as we expected. So I can use bombs. So I can bomb everything and simply can go here and there. And also my bombs won't get reduced and my boomerangs won't get reduced. Alright, so if I fall, I should have 9 lives here. So let's see. Okay, I have 9 lives. So let's go forward. Okay, so if I get hit by the snake, so again I have no problem. I am not my health won't reduce. Alright, so our trainer is work as expected, so you can use this trainer for uh, add lock the variables in any game. So I go and I jump. Okay, I fallen into the pit again. So here I should, let's play it for a while. Okay, so now this is easy to play. So as I mentioned earlier, if you want to use a trainer, first finish the game as without any trainers. Okay, then use a trainer for fun. Alright, so I can one shot kill. Alright, so that's how you do it. So that's our trainer. So we build this trainer from the C#, from the scratch, and that's will be the end of this trainer. So this is the last video, and this will conclude our trainer development series. So I hope you enjoyed this series of videos. So I hope you had fun, you learned something. So again, in previous videos also I mentioned this one. So if you have any questions regarding these developments and this trainer, and please do ask your questions by posting a comment in comment section. Alright, as I mentioned earlier also, I will answer to each and every queries you have by sending an email or in the comment section. And into couple of weeks in time, I will post this C# code to GitHub, and I put the URL to my video. You are in the GitHub in my videos. Alright, so you can download and you can contribute to those also. And that's it. So I hope you enjoyed this, and thank you very much for watching this video. So don't forget to subscribe to my channel, that is One Text with Hashan. So, and also don't forget to click the bell icon so you will be notified when I upload a new video. So thanks for watching, and thank you very much. Stay safe and have a nice week.